Welcome to Chemical Equations Part 2. This slide is about hints and suggestions for balancing equations. A couple of pointers to keep in mind before we begin looking at some examples. Number one, never begin by balancing an atom that appears on either side of the equation in more than one substance. For example, don't start with oxygen. Now what we want to do here is we want to balance the number of each type of atom on the reactant side with those on the product side. And this point is never begin with an atom that appears on either side of the equation in more than one substance. Oxygen is in this molecule. It's also here in molecular oxygen. It's in carbon dioxide. It's in water. So we're not going to do that one first. Second, begin by balancing an atom that appears only once in the reactants and products. For example, carbon or hydrogen in the above equation only appears once. It's only in this molecule. It's only on the carbon dioxide as a product. So it's only there once. Hydrogen is only in one molecule on each side. So that would be a good one to start with. Another point, if an equation contains a free element like O2, a molecular oxygen, balance that element last. That's a good practice, as you'll see. If the equation contains polyatomic ions that remain unchanged on both sides of the equation, these ions can be balanced as entire units. Now we'll see examples of this in some of the problems we're going to do here in a minute. These are some examples of polyatomic ions. The charges on this entire group, OH has a negative charge on the entire ion, the polyatomic ion. So let's look at what we're talking about here. Here we go to the next slide. Here's our first equation. We're going to look at 5 equations. This is the first one, magnesium plus oxygen forming magnesium oxide. Now you notice magnesium is already balanced on both sides, one on each side. So let's look at oxygen. There's one oxygen here, 2 here. Now on the next slide, I'm going to show you a series of equations starting at the top, working towards the bottom of the page. And when we get to the bottom, you'll have a balanced equation. So let's look at this. Here's what we started with on the previous slide. This is not a balanced equation, but let's look at it. What could we do to balance this? We have 1 magnesium, 2 oxygen, 1 oxygen. We need 1 oxygen on this side, or we need 2 oxygens on this side. If we put a 2 in front of magnesium oxide, we'd have 2 magnesiums, so magnesium would no longer balance. Now we can put a 1/2 in front of O2. 1/2 of 2 is 1. So 1 oxygen to 1 oxygen. It's usually not a good practice to do that. It's an alternative. It is acceptable to use fractions of 2 in balancing equations, but you'll see that it's actually much better to use whole numbers. So let's go back to our equation. Magnesium plus O2 forms 2 magnesium oxide. So we're going to go ahead and balance the oxygen. There's 2 of them, so we're going to put 2 in front of magnesium oxide, so we have 2 atoms of oxygen on the right. So oxygen is now balanced. But magnesium needs to be balanced. It needs to be rebalanced. It's no longer in balance, 1 to 2. So we'll put a 2 over here on the left. Therefore, we now have a balanced equation. 2 magnesium atoms, 2 magnesium atoms. 2 oxygen atoms, 2 oxygen atoms in the products. So we have balanced that equation. Now here is a little harder situation with this equation, and we're just looking at it. Obviously we're not going to balance oxygen first, since it is in all the reactants and in all of the products. Since O2 is a free element, we're going to balance it last. So let's balance carbon and hydrogen first. Carbon is already balanced. We've got 3 here. It is balanced. On the next slide we'll show that it's balanced. Right here it's not balanced. 3 on this side, 1 on this side. So let's go to the next slide. When we get down here at the bottom, the equation will be balanced. So let's look at each one of these in sequence. This is just changes that we've made in the equation as we go through. So here's our unbalanced equation at the top. And let's go ahead and put a 3 to balance carbon. There's 3 on this side. Now we've got 3 on this side. Okay, but now carbon and hydrogen need balanced. Carbon, let's see, has 3, and we got 3. But let's look at hydrogen, for example. Hydrogen up here, there's 2 and there's 1. Plus 7 is 8. So we got 8 on this side, 2 on this side. So let's put a 4. 4 times 2 is 8. So now we've got 7 plus 1 is 8. So that's balanced. Now let's look at our oxygen. Notice we've got 1 here, 6 here for a total of 7. Here we've got 1 and we've got 2, but we need 7. So if we take 9 halves, that will give us 18 oxygens plus 1 is 19. Here we've got actually 2 halves of 2 is 9 plus 1 is 10. We've got 4 here plus 6. So 10 oxygen in the products and 9 plus 1, 10 in the reactants. So now we've got oxygen, carbon, and hydrogen all balanced. But we have a fraction as a coefficient, and it's better not to. So what can we do to 9 halves to get rid of the fraction? We just multiply it by 9. And when we do that, actually we multiply it by 2. 2 times 9 halves is 9. So if we multiply this reactant by 2, we've got to multiply all of the reactants and the products by 2, the coefficients. So now we've got 2 in front of C3H7OH, and 2 times 9 halves will give us 9, and then 2 times 3 is 6, 2 times 4 is 8. And down here we can check it. 16 hydrogens, 2 times 7 is 14 plus 2 more is 16, so that balances. We got 6 carbons on the product side. 18 plus 2 is 20 oxygens. 8 times 1 is 8 plus 12 is 20. So this equation balances. It was a little bit of an effort, kind of complicated. Here's the polyatomic ion, OH, that we were referring to earlier. Notice it says it's a group, and it goes all the way over here to the product also as a polyatomic ion. This is an equation that's not balanced, but let's go ahead and look at it. Since OH is a polyatomic unit, I can balance OH as a unit. Calcium balances, notice Ca, Ca, to now balance 2 OHs on the left with 3 OHs on the right, I must multiply to get 6. So we got 2 here, 2 times 3 is 6, so we got 6 OHs here. 2 times 3 is 6, we got 6 OHs on the product side. Now we've got to rebalance calcium because now we got 3 here, so we've got to put a 3 in front of this calcium, so we now have 3 CaCl2. So it gives me 6. Now it gives me 6 chlorides on the right, so I need a coefficient of 2 on the left in order to satisfy the 6 on the right. So let's put a 2 right here. So you can see aluminum is balanced, and the entire equation is balanced with these coefficient numbers. And you can check them. 3 calcium, 6 OHs, 2 times 3 is 6 OHs here, 2 aluminums, 6 chlorides, 6 chlorides on this side. So this equation balances. Okay, let's look at the others here. And here is an equation. Polyatomic ion right here, this nitrate. Looking at it, you can tell that NO3, there's 3 of them on the left, there's 4 on the right. So let's begin balancing this equation using this series. SN and CR balance, 1 SN, 1 SN, 1 CR, 1 CR. So let's balance the chlorides first. There's 4 here, 3 here. So we have to go to a multiple of 12, which would be 4 and 3. So let's put a 3. 3 times 4 is 12 chlorides there. 4 times 3 is 12 chlorides here. Okay, notice now we've got to rebalance the chromium. Okay, so we've got 4 here, 1 here. So let's see what we're going to do. We have 4 here, none here. Or actually got 1. So we can go to a 4 here and a 4 here. So we've got 4 on both sides, 4 chromium on both sides. Let's check this. We do have 12 chlorides on both sides. We have 3 SN on both sides, and we have 12. We have 4 times 3 is 12 nitrate ions. There's 4 times 3. So this is the balanced equation, as you can see at the bottom. Okay, the last one we want to look at is ammonia plus oxygen forming nitrate plus water. And obviously this equation is not balanced. Oxygen probably would be a good one to wait and look at the end, but let's go ahead here. Here's, again, oxygen is free, so let's leave it to the end. Nitrogen balances already, 1 on each side. So let's do the hydrogens first. 3 and 2, so we have a factor of 6. 2 times 3 is 6. 2, let's see, looking at hydrogens, we got 3 times 2 is 6, so we got 6 on both sides. So let's look at hydrogens next. There's 6 on this side and 6 on this side, so we're okay there. But we need to rebalance nitrogen because we've got 2 over here and only 1, so let's put a 2 there. And now we're ready to take care of oxygen. So if we look here, we've got 4 oxygen plus 3 is 7. We got 2 here, so we need 7 halves of O2. 7 halves times 2 is 7. That balances the 7 oxygens on the product side. But let's remove this fraction by multiplying by 2 across the entire equation, all coefficients. So 2 times 2 is 4. 2 times 7 halves is 7. 2 times 2 is 4. 2 times 3 is 6. So here is the balanced equation. So I hope these examples have helped you. In the next lecture, we're going to take balanced equations and use them in stoichiometric equations. It's just a matter of following the rules, mainly waiting to do oxygen or free atom, free molecule type species at the end of our balancing of the equations. Thank you very much.